I think I am totally ready.
Yeah.
Ah, diggity.
Welcome to the Hackaday podcast. My name is Mike Szczys. I'm editor-in-chief of Hackaday.
Hey, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 110. Today we're talking about one Unicode to rule them all, hacking focus stacking, virtual typing, and the zombie weather channel. Elliot, can you spare a diode?
I got tons of diodes. They're like, my closet's full of them.
Yeah, if you need a bigger diode, can't you just hook them up in parallel?
And heatsink them all together.
So what we're talking about is news this week that the United States Coast Guard heavy icebreaker Polar Star is running out of diodes. It is a diesel electric ship, and it uses some mega diodes in its AC/DC rectification, and it's run out of them to the point that they're sourcing replacements on eBay.
When the Coast Guard goes looking on eBay.
Well, I mean, where else are you going to get old diodes?
Apparently, if you listen to the commenters on Hackaday, you just order them up at DigiKey.
Yeah. Yeah, just go to DigiKey has that stuff. They can do that. Well, I don't believe that this is an unsolvable problem, but it's not like this hasn't popped up before. I looked and looked. I know we ran this article and I cannot find it, but the BART transport system in San Francisco had a similar problem years ago, 5 years or more ago, where they were looking for parts to run on their trains and had to source them from eBay, and they were very expensive. Do you remember that one at all?
No, I don't at all.
Yeah, it's something out in my mind. I don't know if I wrote it or not, but this happens all the time. Like, we run great stuff, and it's in my mind, and I just cannot find it on the internet. So search engines are not the end-all, be-all of knowledge storage.
But yeah, what is the end-all, be-all of knowledge storage is the Hackaday comments. I loved how people came in on this one and were like, just order it off the counter. And then there were people who were like, we used to have these super big diodes in our iron smelting rig at my old job, which is awesome. And then finally someone came up and did the math. And so diodes always have a diode drop, right? And if you're running hundreds and thousands of amps across it, then you get a ton of watts dissipated. And Bright Blue Jim did the numbers on this one, and this diode gets warm to the tune of 11 kilowatts when the motors are running full. I mean, when she's full steam ahead.
Yeah.
But
lick your finger before you touch that.
Yeah. So even if you can get these things off the shelf, like how you heat sink them is an interesting question. Like, how do you shed 11 kilowatts of heat? Water cooling?
Ice cooling? It is an icebreaker.
I guess that's true. You just heat sink it to the hull and hope the ice does the work for you. Well, the other bit of news this week was that Crycut has decided to, quote, charge rent for people to use their cutting machines. And this is one of those where they've always had, I guess it's an in the cloud service, and now they've just decided to start charging for it. This is one of those that, to me anyway, has unfair business practices written all over it. And I've actually read what the FTC has to say about this stuff and their guidance to firms who offer services over the web that are an essential part of the functioning of a device. And they say you have to be super clear about it, or else you risk making customers angry. And
I think they made customers angry here, Elliot.
Problem is, when you make enough customers angry, you make the regulators angry. You don't want the FTC to be angry at you.
One note, I think it's Cricket.
If you say.
Yeah, because they have their logo has some antlers on it, like insecty antlers or something. Yeah, so, the thing is, if they have pretty good user feedback that, like,
Sure.
people are like, these are good machines. Like, I've loved this. And what they did is they said that you're going to be able to upload 20 new designs per month. And if you need to upload more than that, you need to have a $10 per month plan, which you could argue whether that's a reasonable program or not. But the point is, people have been able to upload unlimited And even if you go back and look at their old marketing from years ago when people are buying these, it says like, you'll be able to use it for free forever. And so you can understand how people are salty about it. I just don't like the thought that you have to have a web platform for this, because there's really, I mean, it's a CAM system, right? It's just doing path planning. Like, there's no real secret sauce in what it's doing. And so I suspect we'll see an open source driver for it. Wouldn't you?
I think we've already seen a couple people have gone the easy route, which is to just pull out the brain board and put in your own. And, you could do that with an Arduino and an Arduino Gerbil shield for like $8 from eBay delivered. If you knew what you were doing, you could do it in a weekend. It would be a piece of cake. That's what I would do. I guess the other ways are all the like software ways. There's got to be some way to get in upstream on the software. Just listen to what it's sending to and from its web client and figure out what you need to send it to make it do what you want.
Right. I hadn't considered you could just do a web client for it. I thought you'd have to reflash the firmware.
You own the device. Just hook it up to a router, hear what kind of web traffic it's sending, and reverse engineer it.
All right. And when you do, write about it and tell us. tips@hackaday.com.
Yeah, right? All right. Shall we get to some hacks?
Let's do it.
Okay. First up this week is a hack from Charlie X. It's actually about a year old now. Hacking a digital microscope camera for fun and automated PCB inspection. I wanted to highlight this one because it's a forgotten gem. Charlie is looking at an Eakins brand microscope camera, and these are actually really neat by themselves. It's got a little Linux box in it. Among other things, it pops up a menu screen and you can plug a mouse into it. So the idea is you plug this camera up to a monitor, you look at the microscope image on the monitor, but then you can also like record video and take pictures and all of this over its built-in interface. The killer feature of this one is that it's got a little square in the middle that does autofocus. And so it's not just a microscope, it's an autofocusing microscope. And that sounds like a really great thing, unless you want to do what Charlie wants to do, which is focus stacking. And because it's a microscope, it's got a really thin depth of focus. And even if you're only looking at parts on a PCB, if you focus on the bottom, the top's going to be out of focus. And if you focus on the top, the bottom's going to be out of focus. And the solution to this is focus stacking, which is you build a machine that can change the focus as you go up and down. And he's taking it one step further and building an XY platform. So he's going to take a PCB, put it in a vise, move this all around under the microscope at different focal planes, all with the same exposure, different focal points. He's going to get this like mega high definition, super multi-focus image out of the thing, which is a fantastic goal if only it weren't for the software of this device standing in his way.
Boy, that image at the top of this article that Zach Zeman wrote really drives the thing home. It's like a left-right image thing, and you can see it's got like a, 0804 capacitor on it. And on just the stock image, it's all out of focus, the package itself. Like the actual solder joint is totally in focus. But then with the focus stacking, you get it, every surface of it is in focus. And the same with the legs of a dip component. You can see from the shoulder of the leg, the knee. What do you call that, Elliot?
I think that's a shoulder.
Where the shoulder of where the dip leg comes out. It's in focus there. It's in focus on the top of the black epoxy package, and it's in focus all the way down on the board, and like sharp, very close up, because of course it's a microscope. I just loved the journey through this one on how he, reverse engineered this along the way.
Yeah, so the focus stacking software is one part of it. Building an XY table is the other. And then the part that's really neat is that inside this thing is a Linux box. And so Charlie hacks into it like you do with any old embedded Linux machine. He opens it up, solders on serial wires, gets in via U-boot. There's no password on the root account, so from then on, it's basically his machine. He starts modifying some files. There's almost nothing on the thing natively, but he manages to compile a USB network loadable module, loads that into the kernel, and then he's got a standard network connection plugged into the USB where the mouse used to be. He reverse engineers the protocol that the little embedded computer speaks with the camera module and figures out how to make it stop focusing, how to make it stop messing around with the exposure, how to make it do practically everything, it looks like. And then everything is his to control, and it's all runnable over a fake Ethernet through the USB port. So he can then coordinate that with his XY slider and the whole shoot and match. And that gives you these just incredibly high resolution photos. Now, they looked really good to me. And so I went looking into this Eakins camera / microscope module, and they're $500. So they're not exactly cheap to begin with. But if you look at the quality of photos he's getting out of this thing, that's pretty hardcore.
Well, continuing down the reverse engineering rabbit hole, this one is incredible, Elliot. My head was spinning reading through this. It is a Weather Channel rack-mounted box that in kind of the mid-'80s through 2000s, a local station would have plugged in to their racks, and for the Weather Channels on the 8s, it would have pulled down the information from the satellite feed for your local area and overlaid it on the screen. And I hadn't thought of weather on the 8s for years.
Yeah, I looked at the picture of this and I'm like, oh yeah.
It was revolutionary.
1994.
You used to have to, listen to the radio and wait for the current weather to come on, and they would only say so many things. Like, you get a lot of information packed in on that TV screen over a very short period of time. Now, of course, this has kind of gone the way of the dodo because we have the internet now, but put yourself into pre-internet time. It's fascinating to think that they built this amazing piece of hardware that Tech Night has gone into so far in depth and gotten it working again, but this continues to go on, and he's continuing to document it. I just read a new project log that he wrote on it this morning. Inside this box, there are 4 cards packed full of chips on there, and at the heart of it, it has a 68010, so 68,000 series processor, and then the subcards have like 8031 and 8044 processors, but then it also has a whole bunch of PAL chips, programmable array logic. So it has a ton of programmable array logic chips on it, and it has some FPGA chips on it. The crazy thing is there's no software on it. The software to run the thing would have been downloaded into RAM from the satellite feed. And so when this got pulled out of the rack, it lost power and the software is just gone. And Tech Night searched and searched and searched. This software is not anywhere. And he talks about the people that would have built this are all retired now. The information is just poof, it's gone. And I would think 99,999 out of 100,000 hackers would have been like, oh, that's too bad. But not Tech Night. Tech Night actually buzzed out the entire circuit for each of these cards, which is mind-boggling, and then started dumping the logic array from the PAL chips, and then figured out a way to decode that and then roll that into the schematic that he had, and then hooked up with another person who had recorded like a direct feed out of the back of one of these boxes and was able to figure out like the exact colors on the original overlays, and has pieced together from scratch the way that you drive this hardware to get the result you're looking for.
Yeah, this is some serious dedication driven by like ridiculous techno nostalgia. But if you read through the comments, like how many people share this ridiculous techno nostalgia, and how cool is that to get your hands on a piece of like old broadcast gear and get to tweak around with that.
Yeah, 2 years in so far, I say no more than 6 or 7 more years and this thing's going to be unfolded. No, it does bring up an interesting question though. How do you reverse engineer an FPGA? Do you have any background in that?
An FPGA?
Yeah. Like, how do you get the bit stream out of it and figure out what's going on? Like,
Beats
is that
me? Where does it store the bit stream, I wonder? Like a lot of the modern ones require an external memory to store the bit stream on. And so every time you fire them up, they just read it off of an external EEPROM. And it looks like, I'm looking at the board right now, and it looks like there's some EEPROMs, not EEPROMs, but, the old UV erasable EEPROMs on the board. I bet you I mean, they must store some firmware, but if you're saying it downloaded the programs over the satellite, I mean, what if it pulled down the bitstream over the satellite feed? Then you'll never find that again.
No, I mean, he has something. He has the bitstream. He just wasn't able to make heads or tails of it, so he moved on to the PAL. There is persistent storage because he found like the crawler advertisements on it, like an ad for, I think, signing up for Charter Online to pay online, because these would have been taken out of service. I want to say like 2004.
Yeah, early 2000s.
You know, there's some advertising crawling across the bottom of the screen on it, and that is stored locally on the machine, so you don't have to continually keep getting that pulled down or not. But I should look into how you disassemble bit streams, because that is an interesting challenge.
That'd be crazy if they stored the advertisements on that UV EEPROM on there. That'd be lovely. You'd have to update the ads, you'd have to go in there and pull the chip out and put a new one in.
Before they had electronically erasable proms, they would just install UV lights inside of the case and turn them on when they wanted to erase it.
Just put the sun in there.
Yeah.
All right, well, keeping rolling with the hardcore logic hacks of old. This one is a discrete logic word clock by computer nerd Kev. I love this one because I like old logic chips, and apparently Kev does too. He built himself a traditional word clock, except it's completely built out of 7400 series logic chips. Those of you who think that you'd need an Arduino or, God forbid, a Raspberry Pi for this, let me tell you, the 555 people are not far off. What a clock like this does is it reads a shrunk down version of your AC power lines. Kev is in Australia, I think. He's in 50 hertz land. So he then takes this waveform coming in off of mains power, divides it by 50, and that gives you a once per second pulse. And you can do that with logic chips and counters and such. The things that are lovely about this are all the things that make it so ridiculously ghetto. This is like a classic junk box hack. He had some nice hexagonal pattern cardboard, and he uses this honeycomb as the matrix in which the letters are hand lettered. Honestly, it looks like he wrote them with Sharpie on pieces of white paper and stuck into these little honeycomb hexes. He says that other people have said it's unreadable. I can read it. I don't know what they're complaining about. The coolest thing, though, is that then to decode this kind of increasing binary count of the time into what it needs to drive all the LEDs, he has I guess it's a Mickey Mouse logic, old school diode logic array that says, when this one's high and this one's not high, this light needs to go on, and et cetera, et cetera. And he has decoded the whole thing. And it's really interesting because if you do this in a computer, like if you do this in a microcontroller with software and such, you're kind of a little bit further away from, at this time, when this bit flips, light this LED. And here he is like hardwiring the whole thing with diodes. I just love that part of the design.
It also feels like it's a harder problem because you're not, if you're doing a binary clock, you just put all the LEDs in a row and you know which ones to light up. But because you're lighting up the kind of fuzzy time words, that seems like a harder decoding process.
And he mentions that, you don't switch the hours with a word clock on the hour. So when it's 10:30, it has to say 10:30. But when it's 10:35, it has to say 25 minutes to 11. And so, like, there's all of these little weird gotchas. Like, you have to flip the hour over long before the hour should flip over because you're talking about it, right? Anyway, it's a really cool project and, yet another take on the unstoppable word clock. And there's one last bit I want to say before we leave, which is I loved his comment about how he was scrounging these out of his junk box, and some of the 7400 logic chips he had were old enough that they were, quote, made in the dark year of 1974 when 7400 series logic chip inscriptions became hopelessly confused. Imagine the date code on that. I'm not going to solve the riddle. Solve it yourself.
If you want to build something complex, go to IKEA. Or so goes the story for this clone of the Portaball telescope. Now, I've seen pictures of the Portaball before and didn't realize what it is. It's very cool. It has an orb for the base so that it's really easy to aim the telescope in different places. And the amateur engineer wanted to build one of these, and the first thing that you need to solve is how you're going to build that orb. And in this case, a couple of bowls epoxied together was the perfect thing. They have cut into one side of the orb a 9-inch metal cake ring that's perfect for mounting the mirror on the telescope. And then there are some legs extending out, I don't know, like satellite dish style, to hold the lens and the viewfinder eyepiece. And so the light comes in through the lens, reflects off the mirror, and you end up having a telescope. There's kind of a tripod of 45-degree wedges on the base that the ball sits in then, and you can aim it at whatever you're looking for in the sky. Except in this case, a few snags along the way. First of all, it was too lightweight to keep its position, and so the amateur engineer ended up having to cut off the bottom of the orb and put in an 11-pound chunk of iron and then put it back together. And then also, bowls are usually not orbs because they would roll off your table. And so he actually ended up using a little bit of shape lock in order to take the flat part of the bowl out. An interesting thing on this, Elliot, he mentions that it's not a perfect orb, and so you can't put a motor tracking system onto it. I assume that's because you would have like a tooth gear on the outside of the orb that a motor would lock into. Can't you just kind of spring load the motor so it follows the contour and be okay that way?
I guess you could if you put a roller wheel on the outside, but it's got a changing radius because it's got like dimples in it. Then it's going to run fast sometimes and slow other times. So you're going to lose on that.
Precision are important.
If you're going to roll a sphere, you need it to be a really round sphere if you need it to roll at a super constant speed, I guess.
I've never thought of building a telescope before, but I like looking through telescopes, and I saw this one and I'm like, that looks like something I could actually pull off. So it's certainly an intriguing design, and the fact that you can take it places with you is also awesome. But I like the IKEA tie-in. You know, common things turning up in somewhat complex devices is always satisfying.
One more budget hack coming up from me. Injecting bugs with an electric fly swatter. Pedro Javier is looking at EMP pulses and what they can do to running microchips with the idea of kind of, who knows, glitching microcontrollers and seeing what happens to them. What's particularly cool about this build is that there's almost nothing to it. It's one of those $5 fly swatter wands, which makes a high enough voltage at not much amperage to zap bugs when they get into the grid. So what he does is he undoes the entire grid and replaces it with a hand-wound inductor, which is just, in his case, like 8 wraps of wire. And then he needs something to serve as the periodic trigger for the thing, and for that he uses a spark gap. And that's lovely because a spark gap makes a really short pulse when it arcs across, and then it extinguishes itself afterwards. And so what this does is it puts a very short but high voltage pulse through the little wire inductor he's made, which is basically a small scale EMP weapon. And then he takes this coil and he waves it around by microcontrollers that are running a counting up routine just to see if they can be glitched this way. And it's surprisingly effective.
Yeah.
What I really loved about this is he's waving this wand around an Arduino Uno, which has one of those DIP AVR 328s in it. And he discovers that one side, when he waves the wand by one side of the chip, it glitches and makes it get wrong numbers in its adding. And then when he waves it around by the other side, it crashes it completely. And so he speculates that one side is where the RAM is and the other side is where, I don't know, probably the CPU is.
Yeah, I wonder what that does for the long-term stability of the chip.
Probably nothing. I mean, I think you're just flipping bits inside it that are kind of on the fly. I bet when you turn it back off and turn it back on again, it is just fine.
Huh. Well, you're inducing current on the die, right?
Yeah, but probably not all that much. These little electric fly swatters don't put out that much juice. And, then you've got all these funny losses through this inductor and through the air and, imperfect coupling on the inside. I bet you're not going to fry anything. And if you do, you're out on an Arduino Uno. I mean, that's not so bad. He tries it on a bunch of other chips too and gets similar results, so that's kind of fun. What prevents this from being, in my mind, like a really professional, useful tool is that it's really hard to control the timing of these glitches that you send off into the chip. And I was trying to think about ways to hack the circuit to make it microcontroller timable so that you could boot the chip up and just exactly at the right minute hit it, because that often will shake microcontrollers out of their read protect mode, and then you can shake them into debug mode where you can download their ROMs, which is what a lot of people do with this kind of glitching. If you're interested in doing that also on the super cheap, an easier way to do it is through the power supply of the chip itself and not an inductive connection. Moritz von Sievers wrote up a great article just a half a year ago, The Cheap Way to Glitch an STM8 Microcontroller. This is Rumpel Tux, who has a cheap $5 CPLD board and a MOSFET, and he removes a couple capacitors from the target board and is able to time his power rail glitches so that it gives up its secrets. And I wonder if there isn't a way you could do this with the electric fly swatter, but I'll have to think on it a bit.
Now we move to the world of virtual reality, and if you are just tired of doing your 9 to 5 grinding job in regular reality, imagine if you could do all that typing in your cubicle in VR.
Ooh, a virtual cubicle.
I have to admit, I don't like the way that they're selling this research project, but I like the research project, and that is, can you use wrist-mounted sensors in conjunction with the sensors on a VR head-mounted display in order to put a virtual keyboard on the desk in front of you? So you type on just a blank surface, but it's like having a keyboard. The answers are you can actually do pretty well on this, and that's because a lot of these head-mounted VR devices have hand and finger tracking already. What they don't have is a really good way to pick up on the granularity of like which finger is tapping on a surface. And so it combines the positional part from the cameras and the sensors themselves with vibration sensing through your skeletal system based on a couple of accelerometers embedded in these wristbands you're wearing.
Yeah, and I totally agree with you. This is one of those where I love the hack and I would hate to be subjected to this thing. Can you imagine having to slam your fingers repeatedly into the table hard enough that small shock waves are sent up to your wrist to these little accelerometers?
Well, I don't know, man. I've played with accelerometers. They're pretty sensitive.
It's true. There's a ton of super sensitive ones.
Yeah, and the big part of this one, it turns out not to be the sensors that they're using. I think it's cool that they show the hardware, and you can totally pick up. These are LIS2DH accelerometers you can pick up for like $150 on DigiKey or whatever
stuff.
Yeah, and I thought it was interesting because they put them on the ends of flex PCB, and so you wear the little rigid PCB on a silicone wristband, kind of like you would the face of a watch, but then the two sensors are over kind of on the sides of your wrist where the bones are. They tested these along with 2 accelerometers on the rigid PCB, like where the face of the watch is, because that simulates what existing smartwatches and what the Fitbit already have. And so they have kind of a baseline there. And they found that it does perform like marginally better with the accelerometers where they have them, but for all intents and purposes, it's about the same. What is the killer feature here is that they're using a neural network classifier in order to distinguish between your pinky finger and your pointer finger or whatever else. Some interesting things in the paper. This is out of researchers at ETH Zurich. They don't have different classifiers for your right hand and your left hand. They use the same classifier, and then they just invert the axes of the accelerometers,
Mm-hmm.
which is clever. I think as long as you don't have, one hand bigger than the others,
Or you
something
haven't
like
broken your pinky finger in a skateboarding accident like I have. And so it's all like
Yeah.
kind of, I have a little bit of a hook pinky on my left hand because, stupid fall.
Yeah. So who knows? I think you'd have to try it out. And I think,
You could train it on me and then it would be able to discriminate between those pinkies even better.
well, and they do have, so throughout their methodology, they have one set of data points where they do like 10 training exercises to help personalize the thing to you before
good.
they then actually harvest the data. And that actually works out pretty well. So the coolest thing in my mind is that this could totally work well with existing smart wearables, because they showed that the accelerometers in those, the position of them and the type of accelerometers being used are sensitive enough to pick up on this. And so it would be pretty awesome if you could just have a chording keyboard wherever you were without the need for a VR headset. You couldn't have like a QWERTY keyboard like they do in VR because you need the positional sensors from the headset.
Right.
But when you're just talking about chording, which is, different combinations of different fingers would type letters, you could potentially have that for when you're on the go and, I don't know, need to type some computer code into your smartphone.
You are such a cyber futurist. I could see you hacking
Thank
the
you.
Gibson.
Sometimes I use SSH on my phone, and it's kind of super annoying.
Yeah,
to not
it's
have a
horrible
keyboard.
on the phone. Yeah, I do it all the time. It's miserable.
So I always dream of this. Then again, am I going to take the time to learn a chording keyboard? Maybe not.
But where do you get feedback? What do you read if you don't have the VR goggles on?
Your phone, or the smartwatch.
You're looking at your phone screen already? Because then you
Yeah,
can just type it on that stupid keyboard on your phone, right?
I guess, but I hate that keyboard so awful. Like, it has no feedback,
Fair enough.
I mean, go look at my tweets, Elliot. They're awful. I do a bad job of proofreading before I send them. There's extra letters in there. There's autocomplete and stuff like that. I desperately need a keyboard. What's interesting is someone got into the comments on this article and said, hey, now just be careful if you're designing a project around this, because I used to work in those laser projected keyboards. You remember those?
Yep.
They project them on a hard surface, and they said in their testing, they found that people were getting injuries from like slamming their fingers into a surface that has no give to it. Because if you think about keyboards, the key actually moves. And so there's some cushion there to what your fingers are doing. But if it's just like a wooden table, over time, you're just like slamming your fingers into the table. And apparently that can do bad things.
Yeah, you think you get RSI from that bad keyboard you have on your desk. You should try typing straight into the table. My first quick hack this week comes from Science-ish, a YouTube channel I'd never seen before, but I actually really enjoyed. This is experimenting with 3D printed rocket nozzles, and I'm not a rocket scientist, but I learned a lot from watching him run a bunch of different nozzle shapes through whoosh rockets, which are rockets built out of a 2-liter bottle filled with an alcohol and air mixture and then lit on fire. It's not as dangerous as it sounds, and if you have a high-speed camera, you get to look at some pretty rocket pictures. What is that? Rocket exhaust? Rocket... So it's funny little, glowy, blue, thrusty patterns. Next up, the Cognifly project is building a resilient AI drone which packs it in at under 250 grams. This is a research project that's using a Pi Zero and basically all of the Google AI framework and getting it into a drone at under 250 grams. I was complaining about the FAA regulations at the time, but it surely looks like they have fostered a lot of innovation in the under 250 gram category. So it's an interesting unintended consequence. And last up, the e-ink laptop's first steps. This is a project of Alexander's to build himself an e-ink laptop, and I am totally down with the program. He's got a fairly fancy 13.3 inch e-ink screen that has a ridiculous resolution of 2200 by 1650. The catch, the screen itself costs $1,000, but he's trying to retrofit it into some old ThinkPad like T40 or something. I really like the idea, and I really hope he can pull this project off. If you're interested, he is kind of trying to build up a community of people working on e-ink laptops, so go check it out.
First up on my list of quick hacks is Raspberry Pi Cosmic Ray Detector. That's right, Marco built a cosmic ray detector around a Raspberry Pi, but more appropriately around a program from CERN called the Cosmic Pi. This was something I hadn't heard of before, and it's really interesting to go and see how they solved some of the more difficult problems of creating a muon detector. The idea is people can have these all over the world, and combined with GPS, they can be put together into making a world-sized sensor for muons. Next up, PlayStation unlocked with new software hack. Marcos del Sol Vives came up with a really clever way to get around the original PlayStation, the first one, PlayStation 1, I guess you'd call it, security, which is you wouldn't be able to play a game that wasn't on the special discs. And in this case, it's the file name for the save files of Tony Hawk's Pro Skater 2. You can cause a buffer overflow and then execute your own code if you craft the file name just right on one of those game save cartridges. This is a topic that I'm really interested in. How these game systems keep people from copying the games is a kind of cat and mouse challenge. One of the great articles on that Drew Luttrell wrote back in 2018 is worth a look. That one is how the Sony PlayStation was hacked, so I'll throw that in there as a bonus. And finally, I love this plugin for KiCad just because of the topic. It's an anti-tamper mesh plugin that was written by Sebastian Gudel. It is a way of doing a space filling curve with the traces on a circuit board. And the idea is if someone tries to drill into the circuit board or through the case or otherwise tamper with your device, it would interrupt the connectivity or maybe the resistance or the capacitance of this layer, and you would be able to, dump the encryption chips or whatever. I think it's just an interesting look at what plugins can do for these sort of things. And I've seen these on professional devices before and never really thought about how they made them. So it's an interesting dive there. Enjoy. We've reached our can't miss articles of the week. This is long form content written by excellent Hackaday writers. Elliot, what'd you pick out?
Lewin Day wrote us an article from Down Under. They're having a super hot summer this winter and this January. And he wrote an article called Design Solutions for the Heat Crisis in Cities Around the World. And this is an interesting problem of urban design that I thought of in a different way after reading his article. Basically, it's summer down under, and temperatures in Sydney, especially the western part of Sydney, were getting up to 50 degrees C in the air in the city. Now, if you're a Fahrenheit person, that's 122 degrees. That is too damn hot. That is dangerously hot. And some of the problem, although of course not all, is due to man-made architectural problems. That is, about 80% of the surface area of Sydney is covered with roads, pavements, car parks, buildings, and other types of construction. This is a quote from the newspaper he linked in. And almost all of these are black and tar. And so your tar roof shingles absorb heat like nobody's business, and the road absorbs heat, and etc., etc. And this has the effect that it is further warming up the city you live in. And if you live under one of these black heat absorber roofs, it's warming up your house. And so you have to run the air conditioner that much harder to fight it down, and it's warming up the atmosphere around you. It's like a super lose. And I guess that was what I got out of this article. What was kind of new to me was this idea of urban heat islands, that cities are a lot hotter than places with a lot of grass or foliage instead of concrete. I guess you knew this from walking around on like a black tar road in Nashville in the summer where I grew up. But, It's so hot the cats are sticking to the pavement.
Anecdotally, I mean, I've been in my attic in the summer and it's crazy
Right.
hot up there. You know, it's got attic vents, so it pulls in from the eaves and then goes out the ridge vent. So it's supposed to have convection like that, but it's so much hotter than the outside air. And yeah, our roof has insulation in it, but you got to think that that is causing, that's heating up the inside of the house. And if that were done differently, it would be one way for every single house to reduce cooling
So how
bills.
stupid is it that we have black heat absorbers on all our roofs? And this was the realization that I kind of came to after reading this one. This is a huge, I mean, it's the cheapest way to do it, right? And tar
Yeah,
comes in one color, black. If you're gonna put tar shingles up, well, you better like black. But I can't help but think, how long does a roof last? And what's the extra air conditioning bill going to be that you incur for having just a black roof on top of your house? If you could
right.
paint it white and drop the temperature by about 5 degrees C, 7 or 8 degrees Fahrenheit, which you could save a ton of energy in the summer. And that is so bizarre to me that that is not done. Anyway, it was really neat. He linked to an EPA study that said that urban areas are about 1 to 7 degrees Fahrenheit hotter than others. I think this area in West Sydney where they're being particularly hit it's a new neighborhood, and it's kind of built off into the desert. So it kind of gets a double whammy of being inexpensive enough real estate that they can cover it all with asphalt, and being close enough to the desert that it gets the heat coming in from the west. So that may be a place where they really have to think twice. But we read in the comments here that there were some places in India where they were running trials where just painting their roof white would reduce the interior temperatures by kind of 4 or 5 degrees. It's a really interesting, kind of simple, I guess, man-made solution to what turns out to be basically a man-made problem.
We need to give a shout out to Joe Kim on this one because he came in with some art that is just perfect. It looks like a large monolith of
Yeah.
ice amid other red monoliths, and it's kind of like the abstract cityscape with a sublimating or melting ice block
And
in the
also a
middle.
shout out to the Australian town of Coober Pedy, which was an opal mining town. And it's apparently so hot there that they now use the underground opal mines to stay cool in the summer. And they've built like hotels and malls and things down there. So maybe that's another solution. Maybe we could just all become mole men and move under the earth to hide from the hot, hot sun. Or we could paint our roofs.
Now, the moment that everyone has been waiting for. We know that you tuned into the show today to hear about us talk about Unicode, the most exciting topic there is, Elliot. Maya Posh wrote an excellent article, Unicode, on building one character set to rule them all. And it's an interesting topic because Unicode affects pretty much everyone that works on any kind of network-based information trading. Whether you know it or not, you're dealing with it. But how it came about, I would kind of refer to it as like changing the tires on the car while it's already on the highway. Because we started with these islands of computing where you would get a computer and you get a mainframe and you needed some way of encoding information on that mainframe. This actually, Maya starts way back on this. This goes back to when information is first encoded, but I'm going to start with the mainframes. And so, each company figured out what they were going to do for their machines, and that worked because, you would write your programs for that machine, you run them on that machine. It was all kind of centralized. The problem started when we began to add networks to our computers, and then you needed a way to trade data back and forth. And of course, you can trade ones and zeros back and forth really easily, but how you're encoding the human readable data into those ones and zeros needs to be known. And each machine that's encoding or decoding needs to be able to do that. And so we started to see some of these systems coalesce into geographic regions. Like, for instance, ASCII ended up being widely used in the United States. But the problem is it doesn't have a whole lot of data space. It can encode 128 characters. And so when you start to talk about other languages, that have variations on the letters used in English, or you have languages that, like for instance, Japanese, that uses characters that are completely different, you start to run out of space, you start to run into collisions, and a solution needed to happen, and that turned out to be
Yeah, and I
Unicode.
remember this from the mid 90s. There was kind of this like brief moment where it was basically a Tower of Babel again, right? Like from the 70s to kind of the 90s, we had this real ASCII monoculture where just everything was in ASCII. And if if you're German and you can't write an A with an umlaut, you could type an AE, damn it, and just live with it, right? But that doesn't cut it for Japanese, for Chinese, for Korean, for Arabic, for nearly every other language on the face of the earth. I guess it was kind of mid 90s-ish. I don't know. I guess the Latin 1 encoding, which was one of these that's like ASCII plus then you add in that extra bit. Right. So you get 256 characters, and then you can put in the things with accents and umlauts and stuff in the upper bits if you do that. And that was kind of interesting, but then also led to that, screen full of garbage characters if you were interpreting it the wrong way. And then 2000s come around and it just goes all to heck because I may be a little old school. I kind of do like ASCII for its brutal simplicity, but I definitely understand its shortcomings. In that sense, UTF-8 is the best of the Unicodes, and indeed it's won out. Like basically now everything on the internet is UTF-8. And if you ask me, the reason that one versus all of these other encodings that Maya talks about in her article, including UTF-16, which was Microsoft's favorite, and that lost to UTF-8. The reason they all lost to UTF-8 is that UTF-8 is this really clever superset of ASCII, so that the stuff you have written just works in UTF-8, but then you can add all these extra characters on. And the way they do it's really clever. It starts off with that first unused bit in the 8-bit byte that isn't used by ASCII. And then if that's a 1, it signals that there's more bytes to come. And then if the first 3 of that one is 110, there's going to be 1 more byte. And then if it's 1110, there's going to be more bytes until they stop starting with 10. I guess it's a variable length encoding with the smallest version of it is just ASCII, and then the longer ones get progressively more bytes. And so you can fit the entire Latin alphabet into 2 bytes. And then once you get up to 3 bytes, you've got kind of most of the commonly used Japanese and Chinese in addition. And then when you get out to 4 bytes, you've got enough space that you can waste your bits by putting poop emojis in there for all I care.
Well, yeah, and it was that reverse compatibility or backwards compatibility that was really brilliant about it, because if you were just using the ASCII characters, the first 128 characters are exactly the same in UTF-8, even though UTF-8 has the ability to have a lot more bit space. And so if you had a machine that was sending messages in ASCII, all of the new machines would use it. And if you had new machines that were going to communicate with an old machine, as long as they were using just the basic 128 characters of English ASCII, it would totally just work. And I think the other interesting thing about it is the place where it bites us. If you think about strings in C, how do you terminate a string in C, Elliot?
/0, a byte 0.
Yeah, with the 0. So with 8 0 bits, right?
0.
And so you have a challenge when you're implementing this system is you can't send like a 32-bit number that encodes an ASCII character because, the first 3 bytes of it are going to be 0. And so you needed that prefix coding in UTF-8 in order for it to not be sending like 0 terminators.
Yeah, that was a horrible mistake. Don't even get me started on ending strings with /0. That's it's the source of how many bugs, and yeah. I always forget it, so it ruins my day repeatedly. But
I just add an arbitrary number of bytes to every array that I'm using because I know that I'm going to get bit
Well,
by
as if
that
it weren't
somewhere.
bad
And, like,
enough with the like 0 index, 1 index. And so if you're switching back and forth between Python and C all the time, you have to keep sharp. And then the C one has 1 less because it's 0 index, but then you have to remember 1 extra one to slash that 0 on the end. Ah, good Lord. People, there's got to be a better way.
So since 91, we have had the Unicode, and that UTF-8 stands for the Unicode Transfer Format. It came to save us. It's now on version 13 and includes 143,859 characters so far. Replaced that Tower of Babel hell that Elliot was talking about that was the ISO 8859 that had those 16 sets of extended ASCII that just never seemed to work right. That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment on the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send us, so if you've done something cool or you see something cool, please let us know about it. tips@hackaday.com. And until next time,
keep on hacking.
All right, we've rooched
the rump of the wrinkled broggle.
Remember we used to sing quick hacks? Oh, sorry.
I do remember when we used to sing quick hacks, and then I had the machine sing for us, and we've been liberated. Now we could just sit back and drink pina coladas while the machines sing our songs. Somebody's playing bagpipes in the background.
What else do we talk about?